Hey everyone, the Artificial Trainer here. Today I have an exciting new video about Nvidia Cosmos. So Nvidia just recently released this model. It's open source and it's meant to generate data sets with AI that can be combined with real life data sets and um, basically train a robot or something similar to understand a concept. But because it's a pretty good at generating videos for data sets, it's also a great text to video or image to video model that we can use as well. So Comfy has just added capability to use the Cosmos model, so that's what I'm going to be showing you how to use today. So let me just create a new terminal here. Oh, actually, let's go through the pod. So I already have one up, but I would recommend using a 4090, an RTX 4090. You're going to need at least 24 gigabytes of VRAM at this point until maybe if we get some more optimization, we'll be able to lower that. But as of the moment I'm making this video, 24 gigabytes of VRAM is the requirement. We want to use the PyTorch 2.4 image. We have the 20 gigabytes of container disk is fine. 150 gigabytes of volume disk is what I'm using. You might be able to use a little bit less than that. You can test it out. I think maybe 80 gigabytes would be the minimum. And then make sure you're exposing port 8888 and an arbitrary port. I use 3000, but this can be anything as long as you create the right command line argument. Okay, so let's save that. Okay, so let's open up our Jupyter Lab. And we're in a blank workspace here. Let me just update the settings so you guys can see a little better. Okay, so first thing we want to do is we want to install ComfyUI. So let's go to the GitHub page for ComfyUI. And we're going to clone the repository. All right, let's navigate into the folder that we just created, which is called ComfyUI. And then we're going to set up a virtual environment. So python-m venv sets up our virtual environment. And then let's activate the virtual environment with source venv/bin/activate. Okay, virtual environment is activated. And then we need to install the requirements for ComfyUI with pip install -r requirements.txt. Okay, while that's installing, we're going to create a shell script as we go through this so that you can, we only have to do this once, and then you'll be able to just run the shell scripts to do this whenever you want to. So let's put all the commands we just did into this shell script to start. So git clone, navigate into the folder, create our virtual environment, activate our virtual environment, and then install the ComfyUI requirements. Okay, so the next thing we want, we're just going to install a couple of custom nodes here that I like to use. So the first one is the ComfyUI manager. So ComfyUI manager. Here's the GitHub for it. Copy the code, and then git clone ComfyUI manager, and we're going to put it into the custom nodes folder. Custom nodes / ComfyUI manager. Okay, so that'll clone the repository into the folder that we specified. let's just double check that that worked. It worked, so we'll copy this into our shell script. Okay, and then we want to install the requirements for that. So pip install -r, and then I'm going to use the full path here, or I'm not going to navigate into the ComfyUI manager folder. I'm just going to do it like this. That way I can just copy this into the shell script and I don't have to worry about changing the directory inside the shell script. Okay, so that's working. Copy that into our shell script. Alright, so that finished running. The next one the next custom node I want is the video helper suite. So I'm going to do the exact same thing. So git clone the video helper suite into the custom node / ComfyUI video helper suite folder. Okay, let's copy that into our shell script. And then pip install -r custom node / ComfyUI video helper suite / requirements.txt. Okay, so that worked. So I'm just going to copy this into our shell script. Okay, so now you get the gist of how those work. So let's build up the next custom nodes inside our shell script. That way we can just copy paste them into the terminal real quick and make sure they work, and we'll validate it that way. So next I want KJ nodes. This is just like some helper nodes that a member of the community has created. Super helpful. So let's copy that and git clone, and then same thing, copy it and clone it into the custom nodes folder, and then pip install the requirements. .txt, and then the next one is called easy use ComfyUI. So same thing, git clone, and then install the requirements.txt for this one. And then the last custom nodes we're going to install are the Florence 2 ComfyUI nodes. Alright, so let's copy that. Git clone custom nodes / ComfyUI -Florence 2. And then we'll do the pip install. And then, so one last thing with these nodes is just make sure you have a subfolder called LLM right here. Oh, so right here it says you need this subfolder. So we're just going to create that with a make directory command. So right now ComfyUI is our root page, so we want models /LLM. So we're going to make that directory, and when we run Florence 2 commands, it's going to download models into this LLM directory automatically. All right, so let's just run all these through and make sure we did everything correctly in our shell script. So I'm going to copy each command one by one. And just run it in the terminal to make sure it works. Okay. So that is all of the custom nodes that we need. the next thing we're going to do is we're going to install the models. So I have I'll link this web page. This is the README that Comfy provided for the Cosmos model. I think there's 7 models that we need to download, and I'll make sure to link this URL in the description below. So first thing we need to do is we need to download Aria, which is a way to download files fast. So let's update the Linux directory to make sure the Aria download is available, and then apt install. We use the use the yes flag, and we're going to install Aria 2. Let's copy those 2 commands. So we have apt-get update, put that into our shell script, and then apt install -y Aria 2, put that in our shell script as well. Okay, well okay, so now Aria 2 is installed. So let's go get into installing the models. We're going to do it all in the shell script first, just because it makes it easier to copy and paste things, and then we'll copy paste into the terminal. So Aria 2 c-c-x16-s16. So this essentially says to use 16 threads to install whatever, or to download whatever file we tell Aria to download. If you don't use this, you just use like wget, you're going to get like 16 times slower install speed. So that's the advantage of Aria 2. So let's get the first file here. So we have 2 files coming from this link. We have the text encoders and we have the VAE. I'll open in a new link here. All right, so we have text encoders. We have both the FP8 scaled, and we have the FP16. You only need the FP8, but you can download both and try them both if you want. Okay, so we copy that link and paste it into our Aria2C command, and then we use the -d flag to specify the directory. So Comfy tells us to put it into the models/text encoders directory. So models/text encoders, and then our output directory is going to, or our output, our -o flag specifies the names. We're just going to call it what they called it in the directory. Okay, so that's how to download the text encoder. Like I said, if you want to download the FP16, just the same process. Okay, and then we need the VAE as well. So the VAE is here. Copy the link for that. By the way, this VAE is apparently a really cool new VAE. I don't know too much about the technology behind it, but I've seen it mentioned a few times that this may be one of the better VAEs that's been released for AI generation up to this point. Okay, so that is our VAE. We're putting it into the model/VAE folder, and we're calling it just what it was called in Hugging Face. Okay, so that's our VAE and our text encoder. Now we need our diffusion models. So the original models are here if you want to play with those, but they've been repackaged into safe tensors, which we all know are more secure. So if you feel more comfortable using these, then definitely do it. But if you're interested in the original ones, you can check those out as well. There should be no difference in the quality. Explanation of these here. So the text to world models are the text to video models. The video to world models are both video to video and image to video. The 7B model is smaller than the 14B model, but it is less accurate as well. As it stands, you can't run 14B on an RTX 4090. I believe you need at least 32 gigabytes of VRAM for that, which conveniently does fit in the new RTX 5090. So let's get these, get the ARIA2C commands set up to download these. Okay, so copy each one. It's the same process. I'm just going to speed through these. And then I will see, one thing to mention here. Make sure that you put them in the diffusion models folder. And then call the output the same thing. So I'm going to speed through installing all of the, or creating the install scripts for all of these, and you do the same, and then I'll see you after we're done. Okay, so we have all of our install scripts set up. Let's copy these in and download them all. Okay, so this is our text encoder, our FP16 text encoder, our VAE, and then our video models. And so if you don't have 32 gigabytes of VRAM and you just want to download the 7B models, that is perfectly fine. I'm going to skip this 14B model for right now because I'm showing you the demo on a 4090. But you can always just comment them out. So the way that you do that with the shell script is with a hashtag, or you can just delete the lines. It would be good if you're creating this shell script just to leave them in there just in case in the future 32 gigabytes of VRAM becomes more accessible and you want to try it out. Okay, and then we're going to download the last model here, the 7B video to world. Okay, so that's all our models downloaded. Just the last thing here is we want to do pip install Sage Attention. So this allows us to just run video inference a little bit faster, and I believe it also works with Flux too. It just helps with faster generation. So let's just make sure that works. The last thing we need to do is actually run ComfyUI. So to do that, we use the command python main.py --listen --port, and then you want to use whatever port you set up here. So I use 3000, so I'm going to use 3000. Let's copy that over to our shell script before we forget. Okay, and now let's run this in the terminal. Okay, so our GUI started. Let's go open it up. So to open it, you hit connect, and then you go to this this button related to the port that you used. Okay, and then let's just start from a clean workflow here. So we're going to start, I typically start from the K sampler. That's kind of just like where the meat of the generation is done. There's a new sampler that Nvidia created for this called Res Multistep. We'll use that. And then I recommend using either Keras or Beta as the scheduler. 20 steps is good. Around a CFG of 7 is good. So let's pull the model out here. So we're going to load a diffusion model. And then to do text to video, we're going to start with text to video. We want the text to world model. And then I'm actually going to do, there's a couple other nodes that KJ has installed, or that KJ has created. So I'm going to use torch compile we want torch compile. The torch compile node and the sage attention node. And then in the sage attention node, switch this disabled to auto, and then connect these all up. Okay, so this just gives us a little bit faster inferencing. Next, we need our text encoder, so we want to load clip, and I'm going to use the FP8 version for this. And then we want a positive and a negative prompt. There is a standard Nvidia negative prompt that I'm going to use. On this web page, there's actually, the workflows are here. If you want to just download the workflows and put them into ComfyUI, I'm just explaining to you kind of how they work, and I feel like it helps for me to create the workflow myself the first time before I copy a workflow. So this is kind of just a standard negative prompt that Nvidia used in their demonstration. So I'm going to use that, and then we'll do a car driving in a snowstorm. And then connect these up to the positive and negative. And then our latent is going to be a Cosmos latent. This is just the default latent, so we'll stick with the default. And then we need to decode the video. So VAE decode, load the VAE, and then we'll use the video combine node on our output. Make sure the frame rate's 24, and that we have we're using an MP4 as our output. All right, so that is the whole thing. And we can queue this up to run it. I think it's going to take about 7 minutes or so to create the image. I actually might drop this down a little bit. Let's try 960 by 544 just to give us a little bit faster speeds for this demonstration. I realized I made one mistake here. I forgot to change the clip type to Cosmos. Make sure you don't forget that. I'm going to rerun it. Okay, so I got kind of a poor generation here with the text to video. Let's retry it with their recommended resolution, which is 1280 by 704, and see if we get a better result. All right, so decent generation here. Honeywell is probably a bit of a better text to video model. It has less of this kind of glitchiness, but the clarity of the details in Cosmos is great. So we may see even more improvements as the community gets working with this model some more. Okay, so now let's move on to the reason why everyone's really excited about Cosmos is they have image to video generation, and it is probably right up there with Kling, Sora, Minimax, Runway, all of those. It's a very, very good image to video model, probably the best one that we have in open source right now. So the first node we need is image to video Cosmos image to video latent. So attach that. The other thing is don't forget to change your model here. I just recorded a bunch of the video and I still had the text to world model, and it was giving me gibberish as an output, and I couldn't figure out why. It's because I didn't change the model to use the video to world, which gives us image to video and video to video capability. All right, so let's connect up our VAE here, and then we want to load an image. Okay, so I'm going to upload an image here. I'm just going to use a thumbnail from a past video. And then to create our caption for this, I'm actually going to use Florence, which is kind of like an auto captioner. Make sure you download the model. I'm going to use Cog Florence 2.1 large, and then connect up our image, and then change the convert widget input, and then convert text to input, and drag our caption that we're going to generate up to there. And then use the more detailed caption task. And then I think from there we should be good to go. So I'm going to run this. You know what, let's do one more thing. We want to see the caption after it's generated, so I'm going to use the show any node. And now let's run it. All right, so you can see here's our caption that was generated. It's much more detailed than something that I would have written, so that's the advantage of using Florence too. Okay, and then while this is generating, I want to show you how we can create how we can use an existing video to extend a video with Cosmos. So we want to start with the load video upload node, and then we want to drag that into our Cosmos image to video latent, and then we're also going to use the select images node and select the negative first index. So if our video is 100 frames long, this is going to select the 100th frame. It selects the last frame of the video when you use the negative first index. Okay, and then I'm going to drag this up to Florence. And then let's just look at the video I'm going to use. So I have a video of a woman playing violin here. I believe it's about 3 seconds long, so 70 something, yes, like 72 frames long. But I want to generate 121 frames. So this is going to add in those 50 or so frames at the end of the video. The last thing I want to do is look at the width and height of the video. So I think I can use the video info here. Yep, so it gives me the source width and the source height. I'm just going to convert the width and height to inputs real quick. So source width up to there, source height up to there. And now this should extend the video out to 5 seconds. And hopefully we don't even see, hopefully we might not even see where exactly the video crosses over from the original into Cosmos. But we'll let this first one finish generating, and then we'll try this. All right, so here's the video that it generated for us. Pretty good generation here. Definitely better than any other image to video open source model that we have out right now. Okay, so let's try this video extension workflow now. All right, so we're expecting this 3-second video to be extended out to 5 seconds. So here's our prompt. And just some awareness, let's take a look at how much GPU it uses. All right, so it's using maybe 20 gigabytes of VRAM. All right, so it may not have a good data set of a woman playing a violin in Cosmos. You can see it pulls in the curtains pretty well, but the woman playing the violin kind of gets left out. And to be honest, I haven't played a lot with this video extension yet, so I may have done something wrong. Play around with this, do some research on the video extension one, and you might be able to get better generations than I did. Okay, so that's it for the workflows. Hope this helps out with the Cosmos. I think we're going to start to see a lot more coming out with Cosmos like we did with Hunyuan. So I'm excited for that. And the last thing here is I promised I would show you how to use that shell script. So let's close the workflows. I'm gonna stop ComfyUI, and I'm gonna go to the root and delete everything out of here. All right, and then I'm gonna drag in that shell script into my workspace, and then to run it, I'm just gonna do bash cosmos ComfyUI demo.sh. Okay, and now we can just go back here and connect, and it remembers my previous workflow, but you can see we have our models, we have our clip, it's all set up to run again. So that is it for this video. If you have questions or comments or suggestions for the channel, leave them in the comments. I will get to your comments as soon as you ask them and give you my advice or help you out with technical issues or anything you might need. Follow me on Patreon. I released some stuff early there. I had a little bit about Cosmos last week when it first came out. Thanks for watching, and I'll talk to you again next time.